We'll start. Okay. Good afternoon, friends. Good morning, everyone. Myself, Professor Smita A. Takarkar, as an assistant professor in ENTC department. Today, we will learn the practical number third VI characteristics of Pn Junction Diode. VI characteristics of Pn Junction Diode in a virtual laboratory. This is the open source. Go through the virtual laboratory. Here you can register virtual lab IIT Kharagpur. In IIT Kharagpur, open a new tab. This is the new tab. Open a virtual lab IIT Kharagpur, and this is the initiative of Ministry of Education under the National Mission on Education through the ICT Information Communication Technology. Which information? The information of related the technology of the laboratories, mechanical, civil, computer, ENTC, electrical. Number of the labs available here. You scroll it down. Exactly, the basic electronics lab. It's click on that. The basic laboratory. Here, basic electronics laboratory, virtual laboratory. Welcome message here. Then directly go through the list of the experiment, because number of times I am explaining the introduction of virtual lab. In a familiarization with resistor, familiarization with capacitor, familiarization with inductor. These three experiments is completed in a curriculum. First experiment, electronic devices. Today we will learn the Ohm's law and the VI characteristics. In a Ohm's law only, it's a equation. Which equation? Voltage is equal to current and resistor. Voltage is measuring the volt. Resistance, it is measuring in ohm, that's units R. And the current is measuring a milliampere or the ampere, that is the current through the conductor between 2 points is directly proportional to across the 2 points. Which 2 points? One point is the resistor or one point is the voltage. Then the voltage is directly proportional to the current. This is known as the Ohm's law. It's directly proportional across the 2 points, measuring the 2 points of the voltages. Only these equations is important in a Ohm's law. Okay. Then next one, VI characteristics of the diode. You can see VI characteristics of Pn junction diode. It is a simple diode in a semiconductor device. Still here, all of you understand? Link is the virtual lab IIT Kharagpur. Then open this link, click on the basic electronics lab. In a basic electronics lab, choose the number of experiments. In a experiment, click on that and open this VI characteristics of the diode. Experiment number 5. See here the objective. There are 4 objectives. Which one? One is the structure of PN junction diode, function of PN junction diode. It is working in forward and the reverse bias. Forward and the reverse biased characteristics, Which characteristics? Voltage and current characteristic. Voltage is directly proportional to the current because it's a measuring of the current in a equivalent circuits. And last point, forward and the reverse characteristics of germanium diode. But in a syllabus, germanium diode, it's a very less voltage. It's providing the VDC. It's a required of the 0.3 volt is germanium diode. That's why silicon diode is used as a PN junction diode. Silicon diode फक्त आपण यूज करणार आहोत कशासाठी? PN junction diode साठी. Then structure. Here the structure of PN junction diode. This part is already covered in theory, but here some introduction, getting and working, construction working principle. After that, the simulation, performing the simulation. The diode, it's a device. Here the diode. Which diode? PN junction diode. It's a positive polarity. It gets to the anode. Burning electrons, it is a N. N is the electrons, it is created a negative charge. And the P is the positive charge. But the anode terminal, it is created. Anode, it's a negative and cathode, it is a positive. If the supply, if what is PN junction diode? In a PN junction diode, you can see here. In a PN junction diode, this is a symbol. In the upper side, it is a symbol. Anode is the connected to P region. It is a positive charge, and the electrons, it is connected to the cathode. It is a negative charge. But cathode is a positive and the anode, it is a negative. In a supply, this is the supply. Which supply? Power supply. Here the diode. And here one point is the anode, and left side it is a cathode. In a formation of junction, this is the functions of diode. What is the PN junction diode? In a PN junction diode, the P terminal, it's a positive P region, created holes, and in N region, it is created electrons. If the electrons in N region of the electrons is moving left side of the P region and combined with holes, and it P region, it create a negative charge. That's why here the terminal of naming of anode. And the electrons in N region, some holes, it's moving right side of the electrons and it's creating a positive charge. That's why here the naming of cathode. And a PN junction diode forming a junction, PN junction. This the junction, the diffusion process or the depletion process, naming is same. Diffusion, doping, depletion, all words. It's a processing of the PN junction. If the junction, the depletion region, in a depletion region, the recombination of electrons in a increasing of the holes and electronics charge. That is, the charge of the junction is known as barrier potential voltage. यामध्ये कुठला जंक्शन तयार झाला? PN junction. If the formation of PN junction is increase the barrier potential voltage, increase barrier potential voltage, and majority carrier of the electrons is created a positive charge, and majority carrier of the holes is created a negative charge. That's why increasing barrier potential in P-N junction, and the diode is on switch or the conduction state if the barrier potential is increases in forward bias. You can see here in a barrier potential voltage is increases, then the diode its conduction state in 0.7 volt. This voltage is known as cut-in voltage. This voltage is known as cut-in voltage, and the supply is providing through the circuitry. The supply voltage, DC power supply, its voltage increases, then the forward voltage of EF and the current IF is increases because diode is a closed switch. If the diode it is a closed switch, then the current is flowing through the circuitry. Then P-N junction diode in reverse bias. Only one concept is reversed. Diode it is a reverse direction. It is a forward direction. Anode terminal is connected to the P side of the region, and the cathode terminal is connected to the N side of the region in forward bias. But its reverse bias, the cathode terminal is connected to the P region, means positive side, and the N region, its electrons is connected to the, this is the electrons is connected to the anode points. It is also negative. That's why here the diode goes to, after the formation of junction, which junction? The electrons is moving left side of the P region, combine with holes. This is concept is known as recombination of the holes and the electrons. Recombination of the holes and the electrons. After here forming a junction, which junction? The P-N junction is formed. The majority carrier of the electrons is moving to the anode terminal, that is the negative charge, and the majority carrier of the hole is moving in a cathode terminal. That's why here barrier potential width is increased. Barrier potential voltage width is increased, and the diode its open switch. The barrier potential voltage is increased, then the depletion region of the holes and electrons is not moving in one side to another side because it's a causing of the width. Depletion region width is increased. That's why battery is connected positive terminal of cathode is connected to here P region, and the electrons and anode negative anode it is also connected to the electrons. That's why the supply is a positive and negative, but the in reverse bias, but it is a reverse bias P-N junction diode. It's a open switch, and then it is an open switch, then no current is flowing. Here N region it is connected to the positive terminal, and the electrons will also pulled away to the junction. But its effect, its barrier voltage, increase the barrier voltage. You can see these increase the barrier voltage and causing a high resistance flow of the charge. Resistance flow of the charge because diode is open switch. मग डायोड जर ओपन असेल तर करंट कुठनं फ्लो होईल? रेजिस्टन्सच्या अक्रॉस. इफ द रेजिस्टन्स इज कंट्रोलिंग सम करंट बट द करंट इज constant, that's why it's a reverse biasing voltage. This concept is known as Pn junction diode. In reversed bias is a breakdown voltage. It's a reverse biasing the strength of depletion region. Strength यानी increase the depletion region width in reversed bias. That's why barrier potential width is increased and the Pn junction depletion region is a breakdown the voltage and current being constant in reversed bias. Hello, students. Sakshi, Prathamesh, all of you understood working? Okay. Yes, because this is already done in theory, but I am repeated here. Maximum time of the some working constructions you understand. That's why you write down your own words. Then go through the simulation. Sorry, first procedure. See the procedure in a forward bias. How to simulate the PN junction diode and induce a simulation. At a time, its procedure and the simulation we will learn. First, simulation forward bias of silicon diode. Click on that forward bias of the silicon diode. The origin is 0 is 0. Okay. Here the procedure. First procedure, this diagram is similar. Here the resistance is the R. Here ammeter measuring the current. Here the diode, you can see the circuitry. Diode, its conducting state in forward bias because anode terminal is connected to the ammeter and the cathode terminal is connected to the supply, negative supply. And in between, here connected the negative cathode is positive, but here supply it's negative. Then the whole meter is connected to the negative and the positive terminal is connected to the P region. Positive P region, negative N region. Positive P region, negative N region. Here the resistance connected to the supply. This is the circuitry. If the diode, the voltmeter is connected parallel with diode. This is the voltmeter. You can measuring the voltage. आपण voltmeter नि काय करणार आहोत? Voltage measure करणार आहोत. And this is connected to the parallel with diode. हा parallelly connect आहे diode ला. आणि ammeter काय? Series connector. Series आणि it's a series connection through the diode. That's why battery is connected through the circuitry. You can see here the set DC voltage 0.2 volt. Go through the simulation. Here the simulation. Starting set the VDC. You can see here VDC is equal to set 0.2 volt. Okay, each setting. Then after that, step 2. In a step 2, select the diode. In step 2, select the diode. Which type of the diode we can select? It's a PN junction diode. In a select, this is select diode. Choose a diode. 1N4007. This is the PN junction diode. Diode is select. Then third point, set the resistor. Set the resistor. Resistor we can set in approximately 1 kilo ohm because it's controlling the current. Here the 100 ohm. I am changing the values of resistance till okay. 1000 ohm. This is the 1000, 1009, 1000 ohm. 1 into 10 raised to plus 3. This is the kilo ohm. Student, still here you can understand. इथपर्यंत समजलं का तुम्हाला?
Yes, ma'am.
Yes, ma'am.
असं कोणी आहे का ज्याला समजलं नाहीये? First 3 points in the procedure. First point, set the DC voltage. DC voltage कुठे सेट केला आपण इथे? DC voltage. DC direct current we will provide the regulated power supply. Regulated power supply through आपण voltage काय देणार आहोत? 0.2 volt. मग त्याच्या अकॉर्डिंग मी काय कनेक्ट केलं इथे? एक व्होल्ट मीटर and one is the ammeter. The ammeter is connected in the series of diode and voltmeter is connected in the parallel of the diode. Then change the value of resistance. Change the value of resistance is 1 kilo ohm. First 3 points will be done here. Select the diode, Pn junction diode. Then point number 4, the voltmeter is placed parallel with the resistor and ammeter is connected to the series. Point number 4, 5, 6 and the 7. 4 is to one ammeter and the voltmeter is connected. Then the P side of the battery. Here the P side of the battery is connected to the anode. Anode is the negative. You can see anode terminal is negative and the cathode terminal is positive. But the anode negative terminal is connected to the P side of the positive terminal of diode. And anode, sorry, in N side of the cathode, electrons is negative. That's why N region, it is a negative charge, but the cathode terminal of diode, it is a positive. Then sixth one. Now carry the voltage till 5 volt. Okay, vary the voltage. Which voltage? DC volt vary till 5 volt. After here you can see Vf. In a forward voltage is 0.6 volt. Vary the voltage, here value set resistance, ammeter is 0 because still forward voltage, it's a cutoff voltage not crossing the 0.7 volt till ammeter and the forward bias of the current and the forward bias of the voltage is 0. Then click on the adder table, you can see. Left side of the circuit diagram, experiment table, serial number, forward voltage is 0. Here the displaying 0. This is the displaying 0 of forward voltage and the forward current. Current is 0, voltage it is also 0. Then some value you can increase the DC voltage. This is vary the DC voltage 0.3. This is vary DC voltage. This is also 0. Current is also 0. That's why add to table here not respond. Add for the experiment table because it is obviously 0. Till 0.6 the voltage is 0. This is also 0.5. You can see. I am here change the voltage VDC is 0.5. Fast होता है का? Hello. Vedant, Sakshi, Jay. My explanation is very fast or okay? Hello.
थोड़ा फास्ट है मैम.
थोड़ा fast, okay. Here VDC is equal to 0.5 volt. VDC आपण 0.5 volt सेट केलाय. मग 0.5 सेट केला तर मला किती मिळेल? हे approximately 0.6 हवा आहे. It's a 0.6. Then change voltage 0.6. You can see 0.6. Still diode in a forward bias 0.6 voltage. It is a circuitry voltage of voltmeter and the current meter is 0 in forward biasing. But the diode, its conducting state in 0.7. Click on that 0.7. Here the 0.7, some value in ammeter and some value in the voltmeter. This is the add with table. Okay, then add the current. Exactly voltage 0.7 volt will provide the diode its active. That voltage is known as cut-in voltage. Then according to the vary the voltage in DC voltage, see the truth table. I am changing only DC voltage, and according to the changing in DC voltage, the forward voltage VF and the forward current IF, forward voltage VF and the forward current IF. And after that the observation table is finished, we will draw the graph. Then voltage is increased, current is also increased. According to changes in 1 by 1 value. Okay, here the reading number 11, the voltage is 0, VDC. VDC voltage is 3.2, and that 3.2 is the supply voltage. That time in a diode, forward biasing voltage is 0.69 and its current 2.58. Don't change resistance. Resistance is already set. Only change DC voltage. And the last one, 5 volt. Here till 5 volt in a procedure you can see. Point number 6, vary the voltage up to 5 volt and checking a reading. Then after that same observation table, we will plot the VI characteristics. VI characteristics of the forward bias, it's a voltage, and forward current, it is a current. Here the VI characteristics, plot the VI characteristics. You can see V and a forward voltage and I and a forward currents. It's measuring in milliampere, it's measuring in a voltage. You can see the forward current and it's a reading. If the diode it's a conduction state in crossing the 0.7 volt, then the voltage is, this is the VDC. VDC as 0.7, then transistor is on and the reading is forward voltage, it's a 0.5, 0.6, 36, 0.41, 0.47. According to the inputs voltage is increase in DC voltage, the forward voltage and forward current is also increasing. That's why PN junction diode we can use in semiconductor device. Okay, student, any doubt here?
Yes, ma'am.
Then after, okay, which doubt?
No, ma'am.
Okay, then here the print option, you can see my mouse is here, print option, click on this print button. If clicking on print button, the same file is open. This is the file, and in this file you can check the DC output voltage is vary, then observation table also plotting the VI characteristics in forward bias. Save as a PDF file. Whatever destination you can choose your folder, you can save on that and click a save button. Okay, Till here you can understand. Then after that, the experiment, it is a reversed bias. Click on the simulation in reversed bias. Stop this, cancel, and in reverse bias. Resistance and the current is set in reverse bias. In a reverse bias, set the DC voltage 0.2. Set the voltage 0.2. Then here you can see, then next choose the diode 1N4001. Check the resistor. Resistance is 1000 kilo ohm. Set. Here I am and add your table. Add the voltage 0.2 in reversed bias. But here some forward reverse current and the reverse voltage you can see here. But in forward biasing, the DC voltage is 0.2. No supply and no forward voltage is applying here because diode is a closed switch and the conduction period it's required 0.7 volt. But the reverse bias diode, it is a open switch. Diode, it's open switch. Then the current is flowing through only till a resistor. And which current? Supply current. This is the supply current. This is the supply is passing through the only resistor. Ammeter is the constant because diode it's off switch and barrier potential voltage width is increases. That's why in reverse the bias diode it's open switch and it is a break down the voltage. Voltage is breakdown and current is constant. You can check on that breakdown voltage. This is the breakdown voltage 161, 162. Then 3 point means the forward reverse voltage is increased and the current is constant. That is the width is increases, then barrier potential voltage is also increases in reverse bias. You can see only voltage is changes. Which voltage? Forward voltage, because maximum current is maximum voltage is providing here. Here 5.15 volt is VDC. That's why here voltage is constant. Current is constant and the voltage is vary. You can see here 0.100, 0.100, 0.100, 0.100. That is the reverse current. And in a step-by-step procedure, the point number 4 still here. Then point number 5, 6 and the 7. In 5, it's connected to the N side of the cathode, P side of the anode. Then now vary the voltage. Still vary the voltage in the voltmeter and ammeter, check the reading. Voltage is 30 volt in reversed bias. This is the 30 volt. VR is 30. Till 30 volt, we can vary the voltage and checking the current. Current is constant because diode it is a open switch. Yes, na? Hello?
Yes, ma'am.
Yes, okay. Maximum, you can get the reading, maximum readings like a 15, 20, whatever given readings in step by step. 1, 2, 3, 4 according to this serial. This is the reading. Reading is changed after the 29 voltage. Still diode goes to breakdown and current is constant. And see the plot. This is the plotting. करंट कुठे गेलाय? मायनस मध्ये गेलाय. बिकॉज इट्स reverse biasing. Negative terminal, you can see here. Negative n side in this point. Positive terminal of battery. Positive terminal of battery is connected through the resistor, through the ammeter, and side of the diode is N side. Which side? N side. And N side is a majority carrier flow of the electrons only, and electrons is created a negative charge. That's why this negative charge and terminal, it is a cathode. And negative terminal of battery, this negative terminal of battery in a P side is connected to the anode. But the supply, N side of the cathode terminal is positive, and this positive terminal of the cathode and the supply is also positive. Here P side of the positive terminal, P side, and connected to the anode. Anode is the negative charge, and the anode is negative charge connected to the battery of negative. The supply is negative, terminality of the negative. That's why diode goes to its increase the barrier potential width for negative charge and the positive charge. It's a short circuit, means a circuit is open if equivalent circuit. This is the equivalent circuit, and this circuit is short. That's why in reverse bias diode goes to breakdown. Click on the print button, save as a PDF file, save in a proper destination or proper folder like a C drive, D drive, whatever drive you can select on that, and proper folder, BXC folder, basic electronics folder, and save the its outputs. Okay. Then in this subject, in basic electronics engineering, you can save as a theory, save as a PDF file, theory, procedure, simulation, quiz, assignment, and the references. All the data you can save as a PDF file. Don't write in pages. If the college is offline, after that we will give the instructions is take a printout or not. Still you can perform the practical and save as a PDF file and upload the Google Classroom. Next Thursday, you will perform familiarization with resistor, familiarization with capacitor, familiarization with inductor, Ohm's law, and the VI characteristics of the diode. Still experiment number 1 to 5 we will perform. Only experiment number 1 to 4, these are all are the theoretically. There is no simulation. But the experiment number 5, it is a simulation. You can save as a PDF file in a particular folder and upload the Google Classroom till next Thursday. Okay. Till here, any doubt? काही डाऊट आहे का मग याच्यामध्ये आता तुम्हाला समजलं का प्रॅक्टिकल?
Yes, ma'am.
ओके. आणि काय करायचं ते समजलं?
Yes, ma'am.
हा, कमिंग थर्सडे पर्यंत एक्सपेरिमेंट नंबर 1 to 5, 1 to 4 हे थेरॉटिकली आहेत, फक्त तिथे सिम्बॉल वगैरे आहे आणि त्याचे एक्सप्लेनेशन आहेत आणि त्याचे टाइप्स आहेत, रेजिस्टर, कॅपॅसिटर, इंडक्टर आणि ओहम्स लॉ. हे आपलं फक्त एक्सपेरिमेंट नंबर 1 आहे, जे की पॅसिव्ह कंपोनंट आणि ऍक्टिव्ह कंपोनंट आहे. हे फक्त पॅसिव्ह कंपोनंट्स आहेत. Active component directly we will perform in a BJT experiment number 10. That is the already theory is given in a BJT. That's why not extra material is added with the particular this. In the experiment number 1, 2, 3, 4, 5. These all are done. Then remaining 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 and 17. Except the experiment number 5. All the experiments we will perform in a virtual laboratory, save as a PDF file and upload the Google Classroom. And experiment number 7, this is the remaining. For state and verify the truth table, that is the experiment in digital circuitry. In a virtual laboratory, go to the digital electronics lab. ते मी त्यावेळेस सांगेले ज्यावेळेस आपण ते प्रॅक्टिकल परफॉर्म करू. Still you will perform the experiment number 1 to 5 and upload Google Classroom. Any doubt? Thank you all.
No,
Thank you.
ma'am.
Thank you. Here I am stop the recording
Thank you.
first.